Hey, good after evening guys, welcome back to another video here from the Off-Grid Garage. Today with another, it's not a product review, it's a product experience sharing. And I want to introduce you to another tester I bought quite a while back actually, and I've never shown it in any of my videos yet. But I think it's quite an important tester if you handle batteries. So, and now you would think, well, I've got already my multimeter. It shows me the voltage, the amps, it can measure resistance, and some of them can even measure power and other numbers. So why would you need another tester? For what? Well, what I have here tonight is the TR1035 Battery Internal Resistance Tester. And as the name implies already, it measures the internal resistance of battery cells. No, wait, not only for battery cells, but whole batteries. So even if you have a 12 volt, a 24 volt or any kind of configuration, yeah, it can measure up to 100 volt DC. So even very large batteries, you can measure the resistance with it. And I know you can use a multimeter as well to guess, determine, assume the internal resistance of a battery or a cell. Well, there's this delta voltage method or whatever it is called. So you basically take two different currents out of the battery and measure the voltage drop. And from the delta, you can somehow calculate then the internal resistance of the battery cell. If this is accurate or not, I don't know. I've never done it. Well, and if you have seen some of my earlier videos where we have built the battery, and we did the first discharge tests with charging the Tesla from it, we could always see the battery number 6, 7 and 8 were a bit low. And I got a lot of comments under these videos where people actually assumed that the internal resistance are different to the other cells. And this was the time when I actually ordered this internal battery resistance tester. But I have never tested my own battery with this tester yet. And this tester actually used the standard procedure to measure internal resistance. It uses an AC voltage of 1 kilohertz to measure the internal resistance of a battery or a cell. Well, and if you have a look at the EV 280 ampere hours cell here, the internal resistance is actually measured with an AC impedance resistance. And you can find the internal resistance stated in many specs of cells. And sometimes it even says it uses a 1 kilohertz signal to determine the internal resistance. And this is exactly what this little device does. And the tester uses a positive and a negative probe. But if you look closely, you can see it has actually two tips here. And because we are measuring very, very small resistance values, you can probably see here, no, probably not with this camera here. I'll take quickly the other camera here. You can probably see the two tips of these probes. They are formed like a little crown, yeah, so they are really spiky to actually ensure it makes a very good contact to your terminals. And you can see also we are not only having the positive and the negative cable going to the probe. There's also a white cable connected to it, which applies the frequency of 1 kilohertz to the terminals of the battery. And having a look at the specs here, we can see we can measure batteries from 0 to 100 volts DC with an internal resistance of 0.01 milliohm up to 200 milliohms. And this tester has a 18650 lithium ion battery inside. You have got the micro USB up here to recharge this lithium ion battery inside. So very good solution, I think. And you can also take off the measurement cables here as well. It's a 4-pin cable. I can't get it in anymore. There is this one little notch. Yep, there it is. And then it clicks just in. You need to excuse the noise here. I'm doing these AGM tests for Allison, and the tester is so noisy with all the fans. I've tried to block out the noise here with all these boxes around the tester now. So this is a 57-hour test, so it takes a while. Please excuse the noise. Alright, so let's have a quick look at the tester. So we've got our internal battery status here. We've got the auto resistance setting. We've got an auto voltage setting here. It shows us some kind of voltage at the moment. We've got an open loop resistance here, and we've got the power button, a hold 0 button, a range up and a range down button. If we press the power button again, we are going into the menu, so we can do certain things here. I'm not 100% sure what the sorting mode is, but you can set the backlight settings. You've got an auto off setting. I'm not sure what grading settings is as well. RS232. I haven't seen any interface actually on this device here, so I'm not sure if you can connect this to a computer somehow. You've got a calibration mode here to zero your probes. A factory reset. You can set certain parameters here, and then you are back in normal mode. Okay, that's what we are going to use. See, with the up and down button down here, you can actually change the auto resistance and auto voltage settings here. This is just the measurement range you can set it to. Usually it sits on auto, which is totally fine, but you can manually set this to other values as well. 200 milliohms, 2 ohms, 20 ohms, and 200 ohms. And then it goes back to auto. And the same for the voltage. 1 volt, 10 volt, 100 volts, or back to auto. I don't see the point, if it has auto anyway, to change that, but you can if you want to. And then if you have values which are changing a little bit here, you can press the hold button and it freezes your whole display for a moment until you press the hold button again, and then you can read accurately all your numbers. So I have now quickly connected my little oscilloscope here to our tester, and we can see the frequency actually being applied through the probes to your battery terminals. Then we've got a 1 kilohertz signal and about 1 volt. We've got plus 500 millivolt and minus 475 millivolts. So roughly 1 volt is being applied to the battery and 1 kilohertz. This is how the frequency looks like. There, you can see it again. What? Oh, someone donated beer money. Johnny B from Grosvik in Norway donated $10. He bought me 2 beers. What a great idea, Johnny. Thank you so much. Cheers, Johnny. So at the very first start, we are shorting our probe cables here, and we can see we've got 0.00 ohms and all the zeros for the volts as well. So this is pretty much calibrated now to compensate for the probe leads and cables as well. And you can see the probe tips, they are spring loaded to apply a certain amount of pressure on the terminal to make the best contact possible. So, and to measure our internal resistance of this battery here, we use the black probe for the negative, press it all the way down, and the red one for the positive terminal. There we go. And now we can read 12.935 volts. And we've got an internal resistance of this whole battery of 57.3 milliohms. I need to say this is an older battery here actually. This is not quite working anymore. This is one of the older ones. I've got a brand new one here. 12 volt, 9 ampere hour AGM battery. And just to compare this, we measure this one here again. And we should have a far lower resistance. Yeah, you can see we've got only 14.1 milliohms internal resistance. That's pretty good. So, and this gives you already an indication what you can use the tester for. Yeah, you can very easily determine how good your battery still is or how bad it is, and can compare different batteries or different cells together. Okay, then let's test this lithium ion battery here, where we have the positive on the case and the negative up here. Okay, let's test this one. 3.789 volts, and we've got 48.8 milliohms, which is quite high for these cells actually. Okay, let me test another one. 40, almost 50 milliohms internal resistance. That is quite high. And a third one. .47, they're all the same. At least they're all the same, which is good. So if you have such a whole bunch of batteries, then you can quickly measure the internal resistance of all these cells here and can determine if one actually is faulty if you have a very high internal resistance measurement for one of the cells. And I've got two 18650 cells here. One has measured 1522 milliampere hours and this one only 820. Let's see if we can measure the internal resistance of these ones and see what the difference is. This one here, internal resistance 96.6 milliohm, 4.1 volts almost. And now the bad one. Yeah, see, 127 milliohms has a far higher internal resistance, right? And this is an old mobile phone lithium ion battery here, 3.7 volt. We can measure this one as well, if I can hold it somehow. Positive, negative, almost 4 volts and 135.2 milliohms internal resistance of this 100-year-old mobile phone battery. Alright, and of course, incoming! Play the music! Yeah, of course, we have to measure our You Better lithium iron phosphate battery, our test battery here. So let's go directly on the terminals with our probes. This is the lowest resistance of all the batteries we had tonight. 3.3745 volts. And I'm in the wrong polarity. Well guys, yeah, this is exactly what this tester does, right? So I'm very keen to test out our battery now as single cells. So we have to make 16 measurements for each cell. And then I want to determine the internal resistance of the whole battery, of the whole 48 volt battery as well with this tester and see what the resistance is there. Unfortunately, we have to turn off the battery for that and also disconnect the BMS or the balance leads, because there is a control circuit connected through the BMS to each battery cell, and this would interfere with our 1 kilohertz test signal here from the tester, and we would get false readings. So we will do this tomorrow morning, because I need some light then. And when I turn off the battery, there's no light here. So I guess I shall see you again tomorrow morning when we test the battery. Alright, have a good night.
The next day.
Okay, it is now the next morning, and I'm going to do the internal resistance test here of our battery cells. So I have prepared my little notepad here. Yeah, I'm still using paper and pen sometimes. It's just easier while I'm filming here. So all the battery cells from 1 to 8, 9 to 16 I will measure. And as I said yesterday, we have to disconnect the balance leads here at the BMS, because the test circuit for each battery cell is still active in the BMS here. So it is not just enough to turn off the battery, but we also need to disconnect the BMS, make sure there's nothing else connected to the battery cell when we measure the internal resistance. And I will also measure the it's a bit hard now, huh? I also have to measure these cells here at the outside on the bus bar, because I cannot access the original terminal anymore. Everything is covered with a bus bar now. I could potentially measure here in the grub screw, in the set screw, but I'm not sure what is better. So we will have a little bit of higher resistance through that, because we've got a resistance between bus bar and terminal. But I really don't want to take off all the bus bars just to measure the internal resistance. So we have to do it like this. Okay, so I have now disconnected the BMS. So all the battery cells, they should be isolated now. And we will start with one of the easier to access battery cells here to measure them. So I'm measuring here on the outside of the bus bar and the negative as well. And we've got 3.35 volts and 0.4 milliohms. Okay, and now we do number 10, just to give us an idea. 3.35 volts, 0.57 milliohms. And let's do number 9. There's number 9, 3.349 and 0.21 milliohms. Okay, number 12, 0.27. Okay, let's measure number 6, 7 and 8 here on the other side, over there, because these were the cells which gave us problems all the time. So can you still read the display here? I don't know why the light turns off all the time here. Hang on, there was something. How do we in there? Ah, here. Okay. Now it should be easier to read. Okay, let's do number 6, and see if we can see significantly different values there. 0.48 milliohms. Number 7, 0.33 milliohms. And number 8, 0.29. Okay guys, I'll just keep going and then we talk about the results. And just as a reference again, I want to quickly measure our 100 ampere hour battery here. Our test battery again. So we go on the terminals directly. And we've got 0.34 milliohms, sorry. Okay, let's have a quick look at these results. You got all the numbers here on the screen to my left, right, to this side, and we can see a mixed result of all these battery cells. So not quite what I was expecting, to be honest. Especially number 2 and number 10 have fairly high internal resistance. But again, I have measured on top of the bus bars, not directly on the terminals. So maybe they have higher resistance, or there is still some kind of corrosion in between bus bar and terminal. Who knows? But then surprisingly, our problem cells, number 6, 7 and 8, are fairly low in resistance. Especially number 8 has one of the lowest resistance of all cells. Yeah, I don't know, it's a bit hard to tell. Yeah, so I'm not happy with these results of measurement. I think we have to measure directly at the terminals of each cell individually to determine the true internal resistance of each cell. These measurements are including the bus bar and the connection between bus bar and terminal. So I don't think we have the true values here. Okay, before we turn on the battery again, I want to measure the internal resistance of the whole battery as a unit. And here comes the negative. There we go. Of course there's a cable in between now. What do you expect, huh? Alright, this is directly at the battery. 53.58, and we've got an overall internal resistance of about 6 milliohms across the whole battery. This includes all the bus bars and connections to the terminals. 6 milliohms at 53.58 volts. So to calculate the overall short current, we can simply use the voltage we just measured, the 53.5 volts, and divide this by the internal resistance of the battery, 6 milliohms, and we're getting close to 9,000 amps. That's a theory, because the voltage will of course drop if you have a short, and what we measure here is the open circuit voltage under no load conditions. So it might be a bit less, but still an impressive figure. Alright guys, so far this video from today. I think we have to wait until the other hopefully this week. And then we should make another test row of measurements, and we can measure directly at the terminals and don't have the bus bars in between anymore. So I will tell you more about all this. Well, I cannot tell you about this right now, so stay tuned for more updates. As always, guys, thank you so much for watching. Thanks for all your support here on the channel. You stay safe, stay charged, stay safe, and we shall see us again in the next video coming out very soon. As always, I have the links for the internal resistance tester and also the little pocket oscilloscope down in the description under the video and also on my website. Okay, guys, thanks again. See you in the next video. Bye-bye.